Today I wanted to discuss another problem with the Big Bang Theory, and that's the Big Bang's dark energy problem. For those of us that were around in the late 90s and studying physics, when it was discovered that the universe not only was expanding, but that rate of expansion was accelerating, my thought, of course, was, well, now they have to include that into the Big Bang model. Well, they didn't. And it's obvious why, because that would screw up their calculations so bad that, and it was so finely tuned that there was no way that they could come up with a workable theory that incorporates this acceleration. And then they call it dark energy to hide the fact that it's a force. But force equals mass times acceleration. So when there's an acceleration, there's a force. This is a force that isn't in the standard model. So they say, ooh, it's dark energy. No, it's a missing force, you idiot. You got to figure it out. You got to figure out what it is. So we have this force that works on the universe, causing it to expand, if you believe the Big Bang model. If you believe it started at a point and it's expanding. But either way we look at it, you have to account for the expansion of the universe. If it's either real expansion or the redshift is coming from someplace else, possibly. I'm willing to entertain ideas. I'm a scientist, so show me the evidence. So we have this problem. And the problem is even worse because if we have a force causing expansion to accelerate, it means that the force in the past caused the expansion. Some or maybe all the expansion is due to this force. And I really think, I haven't done the calculation or attempted it, someone should have, but for some reason they haven't because it screws up their model. But if you actually did use the expansion terms, the acceleration terms, and apply it going back in time, I bet that it would account for all the expansion. And then, so you no longer have a Big Bang causing the expansion, you would have a force causing the expansion, which is a very different thing, and changes the model drastically. And you still don't have to have a universe that starts at a point, because even though you have this force driving the expansion of the universe, supposedly, it still wouldn't be enough to overcome the black hole problem. And I discussed that in another video, that because all the material in the universe would instantly form a black hole, the universal expansion would stop the instant it formed a black hole, which is the instant it pops into existence out of nothing. So the natural laws of physics invalidate the Big Bang model because of the black hole problem. And the dark energy problem doesn't make the black hole problem any better. So what's really going on? We can think about the speed of light limit for bodies. Because electrically neutral bodies have the same speed of light limit as electrically charged bodies in light, it means that that limit comes from the same place. And not only that, the speed of light is related to the electrical and magnetic constants. So even for non-electrical bodies, you have these constants driving the speed of light. You have an equivalent non-electric permittivity and permeability that give us 1 over the speed of light squared when they're multiplied together. So we have these new constants of space that have the same value as the old electrical constants. And if we think about inertia, we think about a body moving through space, and it's causing something in space to move that's causing the body to move in a form of self-induction. And this self-induction leads to the speed of light limit, like magnetic self-induction leads to the speed of light limit for electrically charged bodies. And if we have that situation, then we end up with a non-electrical Maxwell force. We have a force that obeys all of Maxwell's equations that's non-electrical, where the charge is matter, the amount of matter we have present. And matter is opposed to matter, causing matter to move away from matter, just like like charges are opposed to like charges in electrical Maxwell's equations. So because of that, once we have a non-electrical Maxwell force, which we obviously do because of speed, light limit, and inertia, and other factors, we do expect there to be a force where matter is opposed to matter, causing acceleration and causing the universe to expand. So that fits. Although we have a problem of why is gravity stronger at a close range, but this expansive force stronger at a long range. And that also means that longer ranges, that the gravitational constant G is the sum of two forces working in opposite directions, although who knows, there could be other forces involved. And if there's a Maxwell equation, there are certainly other force terms involved. So the whole system gets turned on its head by the existence of dark energy, because it tells us there's this expanding force. And if we look at the Maxwell's equations and the speed of light limit for electrically neutral bodies and inertia of electrically neutral bodies, it tells us that there should be a force like that. So it fits. But the force doesn't fit the Big Bang model. And Big Bang theorists never changed the numbers. It was before the dark energy was discovered, the universe was thought to be 13.7 or 8 billion years old, and that number is still about the same. It hasn't changed much. Because they never actually factored in the dark energy as a true force, which it must be. So yet again, we have another reason to think that the Big Bang model is invalid. Anyway, I hope you liked the video, and if you do, please like, share, and subscribe. And if you'd like to support my research, I have books for sale on quantum field theory and particle theory. And I have papers and other videos that you can look at as well. And a Patreon account. And I have other videos you can watch as well as my serious technical papers. So thanks for watching.